Okay, hello everyone. This is our weekly API work group meeting. Just to start things off in the use case meeting, we had a presentation related to Kubernetes and EVPN, with some of the work that Intel and Ericsson had been doing. They also made a demo of that. Probably next week, we're going to duplicate that, or at least go through the presentation material so we can see that and ask any questions, et cetera, around that particular topic area. I also posted the link in the Slack channel in case you want to go out and take a look at the recording from the use case group. It's already come out, so feel free to take a look at that so you can get an idea of what's been done and some of the thoughts that are from that perspective. And from that, I want to go ahead and we'll start back into our discussion around Kubernetes and where we see placing the shims and some of the aspects around tying it into the different CNI layers or having the separate orchestration and configuration step, et cetera. So I think last week we left off, Dan, you were talking through your model of the delineations. Did you cover everything you wanted to do with that, or did you want to finish going through that?
I could pop that up one more time.
Sure.
If people are have interest. Let me go grab that.
Yeah, I'm not sure we got through everything that you wanted to bring up.
Let me pull it up. So this slide is from a deck I did to the TSC in December, and we did not get this far in the deck. So the slide is just sitting there, but let me pull it up. Share. And the concept is that I think a little bit of this is similar to the presentation previously, but it's sort of a different offload than Kubernetes. That was shared in the use case meeting earlier, is that if you think about Kubernetes on a bare metal system, and I say bare metal in the term of, it's not in a VM or anything like that, but there's it's just sort of stock, is that there's something running on that host that is setting everything up, setting up the endpoint discovery, adding the ACLs, all of that, and then when one of those pods wants to talk to the network, it talks to the CNI to go get access to the network. So we have been looking at different models of how to offload that. And really, the reason why there are so many different models is because the offload inherently has the potential to change the user interface of either the person setting up the Kubernetes or the person using that infrastructure, and that is potentially a non-starter for certain users. So model number one has the least amount of impact for everyone. It may even be possible to do model number one without having the applications and the pods be aware of that change. But in this case, we're proposing that the CNI, and obviously there are multiple vendors of CNIs, that sort of an entire solution, not just the interface. That the CNI would be modified so that any sort of configuration that would need to be mirrored or proxied into the infrastructure would come from the CNI, and there'd be an agent inside the infrastructure somewhere that is talking that little protocol to set things up. So in our working example today, we set up things like we take the Kubernetes API for policy and we convert that into ACLs into the infrastructure. You know, when there's a new endpoint that's discovered, we push that into the infrastructure to update the load balancer.
But then I feel that we're going backwards. We discussed this approach and we said that it will be impossible except for Felix Calico, which implements a plugin. This is why Intel chose to go with that CNI. It's impossible to influence the other CNIs to actually make changes to accommodate any APIs, including our gRPC-based APIs. This is why this approach is very challenging for us. I think we discussed it all of it a couple of weeks ago already.
I wasn't in that discussion, so sorry about that.
But we can go back, right? You can watch the recordings as well and presentations.
Well,
Okay.
no, but Boris, I asked Dan if he covered everything he wanted to cover from his discussion that he started toward the end of the meeting last week.
No, it's good. I'm not interrupting. I'm just asking if you know, we're going back a little bit for Dan, that's fine. But we already had those discussions. It's kind of repetitive to me.
Okay. Yeah. Yeah, I would disagree that this is a non-starter. You know, I think that this is the point I was trying to make on the Slack is that, you know, when you do something like Model 1 or even Model 3, and I think potentially even Model 2, you in all cases the CNI is modified, and if one of the goals is to really minimize the changes that the end user and or the you know the administrator has to deal with in order to adopt these offloads, then if that's a goal, maybe it's not a goal for OPI. I don't see how you get adoption without that goal. Then you really do need to be thinking about starting with an existing solution and not building out your own. Oh, well, if you want infrastructure offload of Kubernetes, well, you got to dump what you have and throw it away and start fresh. And, you know, that's not the approach that, you know, Antria and even Calico has its own starting to add interfaces for offloading to SmartNICs. So with that, I think that with that assumption, I don't think that number one is we should not toss it out so quickly. Number two is a little bit, I would say, easier if you can go with the assumption that the Kubernetes operator, the administrator, is fully aware that there is this infrastructure blob supporting everything and is going to, instead of continuing to configure the cluster from the hosts, is happy with configuring the cluster from the infrastructure. And so then all the arrows flip, that instead of having the host control everything and then copy state into the infrastructure configures everything and copies state into the host, so that you know, it helps you. The infrastructure is going to drive where those pods get placed, get created, hooked up into their interfaces, and everything is driven from the infrastructure. And this is really similar to I posted last week that the example of how that NVIDIA has been showing how this works.
Yeah, so Vipin's got his hand raised. Dan.
Oh yeah, go ahead. Sorry, I can't see the hands for some reason.
That's okay, I got it.
Cool.
Yeah, thanks. I do agree, Dan, that number one use case is valid. I don't think Boris was saying that, you know, this is not valid use case. I think the main question was how many CNIs have this kind of mechanism to have some layer of gRPC APIs to be plugged into it. Now, if we were to take the entire CNI and run it on the DPU, yes, it's certainly possible, but there's nothing to standardize there, like a smiley that you put in the blue smiley to say where the opportunities exist. So I believe it is in that context. If you can also talk about, for number one, where do you see the opportunities where brownfield CNIs can have, with modifications, of course, to be able to leverage these things. For example, if I were to take Cilium, where do you see that going? If it is OVS, then what is there to standardize? Those kind of questions.
Yeah. So I do think that there would be an opportunity for OPI, for us, to come up with the set of modifications to any CNI in order to turn on these different modes. Let's take number one, for example. We would go to the CNI vendors and say, well, if you want to have Kubernetes networking offloaded by infrastructure, if you know,
Dan, can I interrupt for a second? We're talking primary networking here, and the reason I'm bringing it up is the last discussion was about secondary, so I want to make sure we're level set that we are talking about primary networking here.
Correct.
Yeah, great point.
Just a level set for everyone.
Yes, primary networking is we're trying to take people's existing Kubernetes clusters that don't have a secondary network, or maybe they can have a secondary network, but they're trying to make the primary networking just go faster, or reduce the core, or be able to use more cores for actual work as opposed to Kubernetes. So that's the goal of this, as we discussed on the Slack, is primary networking of Kubernetes. Yep. Yeah, so we could go to these vendors who implement the primary networks of Kubernetes today and say, if you implement these NOPI APIs in your CNI, you sort of discover that there's infrastructure underneath you and that can support them, then you can take advantage of, or your end customer can turn that on, they flip a switch and it suddenly goes faster, or they're using a lot less cores for Kubernetes than they did before. So that would be the value prop that you would go to these CNI vendors, and they would listen.
Definitely, Dan. I think and this is a discussion we had, and something I'm going to also ask again is that, do you see a common API across CNI vendors that we could come up with from as let's say as DPU vendors or as IPU community, to say that, hey, this is a more uniform API that most of the existing brownfield CNIs could support? Because we can come with an API that we can request CNI vendors to look at if they are interested. But the main question was, 3 or 4 CNIs that we looked at work quite differently, and trying to come up with a common API for number one use case would be tricky, in which case it's okay to pick one and then go with it. I'm not suggesting it's a bad idea. I'm just like asking, what are your thoughts on that?
Well, we picked Calico not because, this was the only one that was possible. We picked Calico because of just different market reasons, I would say. And we picked one as opposed to trying to do it for, the top 3 or 5. It was easier. So I think we have the code out of how to do it for Calico, and it's pretty generic. It's figuring out when a new pod comes up so you can route to that pod, in and out of that pod. Figuring out when a new service is capable from a pod to put into the load balancer. And the Kubernetes API for policy is almost like a 1-for-1 translation. It's just if someone adds a policy for a pod, you want to take that policy and put it into the infrastructure. Now, the hard part will be, well, what if your infrastructure can only support 95% of that API? That's a separate issue that we're going to have no matter what. But in order to ask the question, is there an API that we could define that could work for the top 5 CNIs? Absolutely, yes. Yeah, they're all doing the same thing. It's sort of a shame that there are so many, or maybe it's a good thing, there's so many different options in this space. But this would be a valuable bridge. You're bridging from a known application, which is these Kubernetes CNI vendors, to OPI, and would make it sort of very quickly relevant in this space. So I think the work that we've done so far says that, yes, there should be an API that would be common across those different CNI vendors.
Erwin, you have your hand up. You've been patient.
Yeah. If we speak of scenario 2, yeah, for managed services, in fact, if on perhaps, yeah, you have added the CNI on the host, but we cannot enforce, so it's more for offloading features, but we cannot enforce some rules on the infrastructure because if the host is compromised, yeah, in fact, we cannot secure any function on the infrastructure. So I don't know if it could really fit managed services, or if we compare with existing managed services when you have more some enforcement on the infrastructure.
No, I agree. What if you don't trust the host? But are you saying that if you don't trust the host, then really 2 and 3 are the only options that you can take? Or are you saying if you don't trust the host, that 2 doesn't work at all?
Or perhaps not at all, or you should have some option also to put also other infrastructure component on the infrastructure layer, or not. If you don't trust the host, here the infra agent, because if all the rules are defined in the CNI on the host, in fact, you have no way to enforce rules here.
Agreed. Yeah. So one thing that was in our presentation is that in order for this to work, you really do need a direct connection between every pod and the infrastructure. So whether that's SRIOV, scalable IOV, or something like that, or you have a VM connection for every pod. That's the only way that you can enforce these rules, because if there's some connection in the host that is fanning out to your pods, then that's outside the scope of the infrastructure. You can't apply those rules and enforce that. So that is sort of step one, and it's not shown in these pictures, is that you have to have that direct connection. And I think once you do have that, then that makes it so that you could run something like a 2 or a 3 and not trust the host. But you would be applying the policy on that port that you assigned, not necessarily the pod, because the host could go and swizzle the pods around, but at least you will have applied the policy on that port.
Okay. Prasad, you have your hand raised.
Yeah, thanks. So I'm very interested in this item 2 for a couple of reasons. One, I think that closest to like a transition model, right? I think your example was right. Somebody transitioning from situation 0. Situation 2 comes closest to me when you introduce the DPU. And I'm a little at loss, maybe you can explain. I think the amount of changes you anticipate can be significantly reduced if the CNI that you have shown there, actually maybe the entire CNI there runs in the infrastructure, and even the kubelet, instead of being a modified, or maybe it's a modified version, so it does some local pod launches and some on the host. So I don't think you need a change to the host, is my thought, except for a thin CNI. I don't think you need a modified kubelet agent, is my anticipation. And I think the role the OPI could play is that you don't have to sit between the Kubernetes control plane and the kubelet agent. Instead, it could be completely sideband, because now you're OPI aware. You're trying to program the green box completely separately. And your infrastructure and your Kubernetes orchestrator master do not change, because they just see the host as it was before, with the DPU just playing man in the middle. What do you think of that? Do you see I'm not sure why you have so many red boxes in question.
Yeah,
I think-
I don't see how you, I think you just described something that's very similar to like infrastructure as a service, right? Where you just, you pop in a virtual port, maybe some virtual disks into the host, and then they just get used. Is that what you mean? Or
Yeah, I think yeah, I'm piggybacking on the other explanations you gave. Yes, indeed. So the assumption is you still have port level control. CNI is the concept. I mean, if you headed towards service mesh, that's more challenging, I think, because that's at a higher level on the host. But at least at a pod IP level, the CNI level, I don't see why. I mean, just to answer Vipin's question, there's no reason why the entire Calico, Cilium, or whatever else cannot run fully on the infrastructure, right? Because if you run the whole CNI in the infrastructure, you have secured the pod anyways, the interface to the pod at least. That is the fundamental assumption, of course. But
Yeah.
some of these CNI do go higher up, which is into the service mesh category.
So yeah, wouldn't that be like the fourth option where your whole CNI is running down on the infrastructure?
Yeah, I was thinking option 2 itself. I don't see why CNI, even in option 2, why is what forces CNI to run up there? I guess that's my real question. I think it can just run in the infrastructure, even in this. It's the same model. There's no change in the model. Actually.
Yeah, I think you might be right. I think that maybe it's an issue with the picture is that potentially just the logic of applying all the ACLs and doing all the forwarding and such is still happening in the green in the infrastructure. And then, inside the host, you just sort of have a port that pops out. And then you do need that kubelet agent in there to do placement of the pods, to just, assign them to their ports that they have been, given, and then you're off and running. So that's definitely I guess the spirit of number 2. I agree. The picture isn't great, but that's why there isn't a smiley face on that CNI arrow, is because all the smarts is happening in the green, and then the CNI that's really just a port. So I can update that picture to make it more clear. I think you're right that really all the CNI is in there, and the only thing that's popping into the host is a port, and then you have, or a disk, and then you have your some sort of Kubernetes agent. This is really similar to how we do IaaS. So it's just matching up your business logic with the infrastructure resources that have been allocated. So I'll update the picture. I think that's a really good point.
Okay, yeah, that makes sense. And I don't think a new prototype of standard is needed either. The smiley is not required. Instead, I would think OPI would be sideband, a complete separate arrow, independent of the Kubernetes architecture. Whatever is set up in situation 0 would not have to change outside of this. That's my thinking.
But you would still have the indirection that you have in IaaS, right? You would still have the indirection to say, normally in Kubernetes, here's the business logic. I just plug it in directly, right? But here I have to say, all right, I have my business logic pod, and I have this other port number 5, right? That I want to put this pod on port number 5. So I got to go do that. So there's still changes there. It's potentially a different set of changes than number 1, but you still have to do something there. I don't think it's sideband.
Just thinking it can be done completely independent of Kubernetes. Sideband, a separate arrow from a separate controller. It doesn't have to be the K8s control plane is my thinking. Did that make sense?
Yeah, that possible. Yeah, you just do the indirection totally on its own separately. So
yeah, I understand you don't need control over how the DPU behaves. So that's where I thought would be complete OPI. So whatever we are coming up with now would help dictate the behavior of the DPU. You do not alter the existing deployment basically, except for, so earlier I think you were saying instead of flipping a switch, you could have hosts with and without the DPU. The ones with the DPU would show an increased mileage versus the ones without. That's the way I imagine it. No change needed outside.
Well, I mean, your entire deployment changes, right? So on your host, you're not deploying Kubernetes on the host anymore. You're deploying it on the infrastructure. Yeah, that's a pretty big change, right?
Only on that host is what I'm saying. So you could have another host in the same cluster, which doesn't have the DPU on it. There's no change outside of that host is my thinking. So you don't need that smiley part. That's where I'm a little perplexed. Why is that coming in? It could be exactly same as from an external perspective, the host with the DPU and the host without the DPU appear exactly the same, is my thinking, to the K8's control plane.
And you're talking about the smiley on 2, right? I want to make sure.
On two.
Yeah.
Item.
You're saying move the smiley inside the green part and have it just sort of copy the information of like, oh, you want to put a pod inside this quote unquote host, which is actually infrastructure. I'm not going to put it in the green. I'm going to go move it into the orange. And is that orange? And then give it a CNI and give it some disks or whatever. That makes sense. I see what you're saying. Okay. What I'll do is I'll just change 2 entirely to be that model that you described. I think that makes a lot of sense.
Okay. So yeah. So okay, maybe not right. So the smiley doesn't go inside the green. It still talks to the green box, but it doesn't have to come from the K8's control plane. It can be a complete separate agent.
Okay.
A new for the DPU.
Got it.
To control the DPU. You don't have to disturb the existing operation is my thing.
Prasad, there are 2 things here. Sorry to interrupt. There is a Kubernetes control plane that is spinning up those agents, but I think the Blue APIs is configuring the infrastructure part on those pods which are running on the infrastructure plane. So there are actually 2 APIs in the sense, one API to spin up these things, which is what I believe the Kubernetes API is. But then there is real APIs to go configure the infrastructure component there. I don't know whether you are thinking that both of them is combined into one or
there's no Kubernetes dependency on that second one.
Yeah, I didn't show that second one. Yeah, that one definitely exists, right? These infra agents have to be talking something at the bottom, and I just didn't draw it because it was not what this slide's for. But I agree with you. Yeah, there's another interface that we likely would also want to define.
For example, a simple situation is somebody programs a DPU to say, do not run any CNI on this DPU, right? So then you just fall back into the first model. Everything is just running on the host. The DPU is playing dumb Nick. So you just fall back into step 0 by a mere configuration.
Yeah. Okay, and then the third model here is just the sort of a similar. It's just a combination of 1 and 2. Is that, and of course all the changes to 2. 2 is not something that we have implemented or tried. That's why I think that I drew it wrong. Is that if you combined this sort of self-managed solution with where there's a managed service for Kubernetes happening, where you are setting it up in the infrastructure directly, you could easily imagine that the ideal is actually to have it split, where there's some things that the tenant wants to control and set up. They want to place the pods. They want to figure out how they use the compute and other resources on that host. But when it comes time for them to get into the network, get into their storage or whatnot, that's controlled by the infrastructure. There becomes that part is managed. So I think that 3 is where eventually we want to get to, where you sort of have to have both. So that's why I think 1 and 2 are valid in terms of, hey, we probably should get 1 and 2 working first, but then eventually, get to this third model, which has full flexibility.
Billy, you got your hand raised. You've been patient.
No, sorry. Yeah. So on 3, why? I know we've talked about this before, Dan, but I just don't get why the Kubernetes is red. What's changing in Kubernetes? I mean, I would like Kubernetes to stay gray. It's not modified or enhanced. I mean,
Yeah.
And I don't call enhance, like if I want to create my own CRD, that's not enhancing Kubernetes. That's just leveraging Kubernetes. So
yeah, I would say that I bet number 3 has just as many drawing issues as number 2, because we just haven't gone through it.
Okay.
And I think that would be a great goal of 3, is to say like, hey, we're not going to really change Kubernetes that much, but I do think that there are changes beyond just CRDs where it's a split, right? And maybe actually, I think some of the stuff that in OpenShift is maybe anticipating this a little bit, but you know, I don't see the split currently in current deployments, which is why we drew it red. Maybe it's not necessary. Maybe.
Okay, well, I would like to, I mean, my assumption is that we shouldn't have to, well, hopefully we wouldn't have to change the Kubernetes control plane. We can leverage its features.
Yeah.
But, so, you know,
that would be great. That'd be great.
And then I want to go, I raised my hand back when we had the discussion on one, but it's fine. So we came up with, at least Red Hat, we presented like 3 weeks ago, there's some scenarios and that we wanted to decide if everyone had the same talking points, you know, so that we could kind of level set. And one of them we had was scenario one. I don't have it in front of me. I think it was scenario one, where it was more talking about a brownfield case, and you say it should run on the host. And so for something like Cilium, I kind of think it should run down on the DPU. And my justification or thinking for that is, you know, Cilium's doing, like, on top of just using like Linux bridges and stuff, they're doing a lot of eBPF, and it's not just networking, but they're also doing a lot of observability and dropping, you know, eBPF to do this type of either observability or network policy. And for OPI, that little smiley face, to have to implement all of that, it seems like to me, if we wanted to move something like a Cilium down on the, you know, to run in this deployment with the minimal amount of changes, we would just run that directly on the DPU. He may not be able to take advantage of any acceleration through whatever, you know, means are on the DPU, but you would at least be running down on the DPU and controlling the networking. But you seem to keep pushing it back up, and I just want to kind of see if what you know, the difference there, as far as, and granted, I tend to go straight to Cilium because of the eBPF reasons.
Yeah,
because we don't want to try to keep up with eBPF in an OPI API. There's no way we would do that. And so in order for something like a Cilium to truly function and have its special sauce of observability and whatever it's doing for network policy, I kind of feel like it needs to run down on the DPU, but not necessarily, you will never speed it, or you won't speed it up until it makes calls to, let's say, accelerate some type of encryption or other ways that they find to accelerate it later.
Yeah, no, I disagree with that. I think that our mental model has been Cilium, Calico, they do like 100 things, right? What if the infrastructure could just pick 3 things to offload, and then the other 97 things are unchanged? And that's why I think the CNI for 1 and for 3 needs to stay on there so that they can continue to do all those things. It's really similar to how the Google Cloud works, which we talked about a little bit in that KubeCon talk, is that, you know, Google Cloud today can offload the routing for you in Calico. And I think for a couple other, and they also use Cilium for all of their policy today. So you know, there's going to be so they've already demonstrated the case where I'm using Cilium for those 100 things in Google Cloud, but I have a pathway to be able to offload just the routing between my pods, so I don't have to run, you know, I don't have to run BGP on my host and like know what that even stands for. So, you know, that's a big benefit without having anyone to go and move something very valuable off of the host. And so I just think that could never happen, right? Like there's always going to be that one thing that they need to be on the host for to be able to apply that, or, you know, you're going to create this huge barrier for those vendors to innovate. So that's why I think it has to stay for 1 on the host. And I think that's why 1 is also much more valuable than 2. And I think we all agree now that in 2, the CNI moves into the infrastructure, but you've just kneecapped that CNI. No longer, other than that information of like what port the traffic came from, they've lost all the other information that that they're accustomed to by running on the host. So I think that is the biggest barrier to is that you're relying on 100 different things inside the host in order to make that CNI work. So really the argument to these CNI vendors is that no, we're not trying to replace you. We're not trying to move you off the host or offload you. We're just going to take the relatively expensive networking functions, or maybe they have really expensive control planes like routing, and offload those.
I think a couple of things I want to add. There's some good examples as well, right? Calico, for example, has an accelerated version with VPP. Cilium uses eBPF. OVN does OVS-based acceleration, OVS DPDK-based acceleration. So that means these CNI vendors do see a need for accelerated CNI, and they've been solving it through some of these other applications. So from that point of view, I think moving down the CNI helps, because OVS DPDK can be accelerated, VPP can be accelerated.
Well, we use the VPP. We use a lot of the VPP constructs in Calico when we did this offload to the infrastructure. Yeah, it's sort of making it generic, right? So that doesn't necessarily have to be VPP specific when you start moving the routing out of Calico. No, I think both approaches are valid, but I think in one, the big difference between 1 and 2 is that the CNI stays on the host.
All right,
Yeah,
I'm gonna have to, I'm not sure if I buy your argument yet, so, but we can continue. I don't want to hold us up here.
Okay, no worries. Okay, that's all I wanted to show. I didn't intend to take 40 minutes.
Sorry, Dan, just one more question there.
Yeah.
In the split tenant and managed infrastructure, so scenario 3 that you have here, do we really envisage that the infrastructure will be driving all of the decisions? And the analogy I would make is, if I go to a shop, and I'm the tenant, then I would know what I wanted from that shop, and I might ask the attendant to point me in the right direction or to give me the thing that I want. And the idea here is that we already have all of these resource pools set up that the tenant is completely aware of. Is there not an opportunity to have this split responsibility where the tenant can decide, for example, which VF it actually wants from a resource pool and indicate that to the control plane, rather than the control plane telling it, here's a VF, off you go?
Oh, 100% agree. Yeah, there has to be. That's why I think those two red pieces change, is because there has to be some sort of.
Yeah, it's more to do with the arrows here, in that it was probably more bi-directional rather than the control plane just pointing up into the tenant. And the other thing is, if we follow this kind of model where these CRDs are kind of shared across the Kubernetes control planes, both the tenant and the infrastructure one, then that blue dot that you have under CNI becomes driven through CRDs, and it doesn't actually, it's a logical one rather than a physical one. The infra agent will be reflecting stuff on the DPU, but it'll be all done through CRDs and that kind of a model, rather than having an explicit blue dot that's interconnecting the CNI or the infra agent via like a gRPC API. And I think that leaves us with a much cleaner kind of way of doing things in the Kubernetes world.
Yeah,
that would be my feedback.
Yeah, I'm going to redraw 2 and 3 with all this feedback and post it to the Slack, and maybe we can iterate on Slack and this is really good.
I would kind of add, an extra box to the left-hand side of the 2 red control planes, which is like a message broker, essentially.
Yes.
That's what I would kind of leverage. And that way you kind of end up with this really clean layer between the tenant cluster and the infrastructure cluster. And it becomes very clear that the APIs are self-contained within the context of the DPU.
Okay. That's very helpful. Yeah, but that's the split, and maybe we can do that split cleanly without having to make tons of changes to Kubernetes, or just, it turns into just a contribution to Kubernetes as opposed to something specific to OPI.
Yeah, hopefully. And, if you kind of create stuff through CRDs, I'm hoping
Right.
that it becomes relevant in both scenarios, whether it's singular cluster or multi-cluster, because essentially, you're only kind of reflecting stuff in a different way to the DPU, but the messages would remain the same ultimately. And there's lots of CNIs today that move VFs into, from host network namespace into pod network namespace. So there's not a heck of a lot of work that we need to do on that front. Maybe for sub-functions, if we want to create something that's much more dynamic. But for me, the CNI should stick to the concept on the host side that it is a dumb binary that runs to completion and just does the simplest thing of moving a VF into the pod namespace and actually configuring it with the right IP address or whatever based on information that it's given.
That's right. Okay, that's interesting.
On one part also about the dumb interface is we have seen also on labs POC that if it's not dumb, it's a risk of life cycle compatibility it's also something that deploying on a lab one day on running on thousands of nodes for years, if the demarcation between the two layers is clear, it's help also to run at large scale.
Yeah, that makes total sense. Yeah, so you can't, that little up arrow into the CNI needs to be in the infrastructure, and then that whatever's on the host has to be dumb, like you said, has to be a port.
Yeah, and the model I presented before is, I think, similar to the model 3. And my thought process is basically OPI API should be defined in such a way we have basically tenant, operator role isolation. And also should be defined in such a way we can support bare metal as a service model. And Kubernetes is basically the extension for that model. And if you think about a bare metal as a service, you basically give the tenant the bare metal system, then you really cannot set up anything from the host side. So you basically set up the VPC or VNIC or firewall from the infrastructure side. And the network will be set up through the DHCP. So the up arrow to the CNI, in my case, is basically DHCP. So you just set up all the network information from the infrastructure side and give it to the network to the DHCP. And if you do that, then basically the functionality I proposed is the provision VPC, VNIC, and firewall and load balancing. So if we have that set of the APIs, then for the Kubernetes, we can basically continue to use the Kubernetes API between the control plane and the kubelet, or control plane the kube proxy. We don't need to change that part of the APIs. And if the CNI has a CRD extension, that continue to be used. But then we only look at the backend side of the kube proxies or network policies that can use the basically the OPI API to set it up, which is the firewall or load balancing. And that API is basically common for the bare metal as a service model or other basically the use case we can think about.
No, I think that's a valid use case, but I think that's a really different use case than the one that we're targeting here. Like, yeah, it's supporting bare metal as a service, and basically there's nothing on the host that you control. You can do that with OpenStack Ironic. You can do that. And obviously all the cloud vendors have their own solution. You could do that with Kubernetes networking, but it's a different use case than supporting Kubernetes running on a host that you want to accelerate. So I think it's a very valid use case, but I think it's different. In IPDK, we have a different recipe for that. We just call that the networking recipe that supports bare metal hosting, and doesn't necessarily dictate that it has to be a Kubernetes control plane versus OBS, OBN type of thing. So I agree with you on the use case. I just don't know if we want to peanut butter that across with Kubernetes offload as well. I mean, we can, but
yeah, I kind of agree with you there, Dan. And I think it's important to create that clean delineation. Like the infra agent might be able to do all of these things, but for Kubernetes, I don't think we necessarily wanted to do that, you know. And the most basic thing I can think of is, what if you have multiple DPUs on the host, you know? Things get relatively messy if you don't have clean separation of the clusters and the APIs and the behaviors.
Yeah. Okay. I'm going to stop sharing so I can see if there's any more hands.
Yeah,
okay.
Prasad just raised his hand.
Yeah.
Oh, go ahead.
Just want to add, what Toshi presented, I thought was for a secondary network, right? Not, I mean, it assumed an existing connection to the Kubernetes infrastructure in addition to a DPU connecting to the same infrastructure. So I thought at the outset you had said this is for the primary, which is what makes sense to me. What we're talking about is the DPU is the primary connectivity agent for the host, right? And it's the only one. So I think two different models even from that point of view, I think.
Toshi, do you agree? Or I thought it was for primary, actually.
Yeah, I also thought it was primary.
Yeah, it is primary.
But there were two NICs, right? I think I had asked this question. There were two channels. It's like there was one that was bypassing the DPU. I think you had given Amazon ENI as an example for that.
Right. We basically isolate the host, and the VNIC attached to the host for the host network network space is also in the same VPC. So this is similar to what you have in AWS. So if you have an EC2 instance, all the ENI network interface you attach to EC2 is same VPC. And within the same VPC, you basically allocate one for the host and allocate one for the basically the other services. And in this case, we can attach to the pods.
Okay, so maybe I'm still confused. That's still two interfaces for the EC2 instance, isn't it? One that
yes, we can set a rule for the port basis, as the Dan mentioned. So we have to dedicate a VNIC for each pod. So if we have the 10 pods, we create 10 VNICs and attach to the 10 pods. And we need the one additional VNIC to the host. Does that make sense?
Okay, maybe I'm the one lost. But so when you say additional VNIC to the host, you're saying that is still coming from the DPU, is that?
Right. So the VNIC to the host and the VNIC to the pods share the same VPC, but they may be a separate subnet.
Okay, I got it. So somehow in your model, the host and the DPU are behaving like there's an opportunity for them to behave like independent entities, even though they are like connected via a backplane.
Let's say we create 8 VNICs and assign the one VNIC to the host, and the rest of the 7 can be assigned to the pods.
Got it. Okay, makes sense. It's different.
All 8 are in the same VPC.
Okay, I get what you're thinking. Okay, thanks for clarifying.
Sure.
Oh, Vipin, I think you raised your hand.
Yeah, one of the most important thing that came out to me from today's discussion is what Dan mentioned. There is an opportunity to define a common API for brownfield CNIs to be done, and I've seen the adaptation that IPDK code has shown. Dan, it will be good to actually look at and examine that API in subsequent meetings to iterate on it and see how we can standardize it. I feel that would be a good step in the direction of trying to leverage brownfield CNIs while trying to make the relevance of all the DPU related acceleration that is out there. What are your thoughts on taking us through the API, the gRPC APIs that you have created for offloading Calico? And like you said, it doesn't have to be Calico, but is that looking generic enough? And could we have a discussion oriented around that kind of API to say whether that is what we want to standardize or that is what we want to build on?
Yeah, we absolutely could do that. And we have Nooper here on the line. She's been working on the APIs, so that I think Nooper would likely present, and we could go through the APIs that we've found so far with Calico, and then also sort of discuss which parts are Calico specific versus things that could be totally generic. So
yeah, I mean, it is a very concrete thing than a lot of arrows and diagrams moving around, which is okay. I think we have to hash out all possibilities. I'm not denying that, but that is one of the more concrete things that we could at least put things in perspective about the models you presented.
And definitely, Vipin, we can do that. We actually looked at a couple of implementations to figure out the common interfaces, and we can present on that.
Yeah, okay, awesome. Thanks.
Okay, I'll coordinate on when we can do that. All right, everyone, we're getting close to the top of the hour. This was a good discussion. I'm glad we kind of circled back to walk through everything. I think our next goal should be to really start to dive into the lower level. Let's start trying to figure out, beyond looking at the different APIs, but let's start looking at what the different shim layers should be, what the structures need to map out to, and start kind of laying out a set of diagrams, use cases that will address this. I think we've got a lot of data that we've gone through between what Billy's presented, what Toshi's presented, what Dan just went through. We've got a lot of different concepts here, but now I think we need to start digging down to the next level if everybody agrees with that. And with that, I'll go ahead and close out the meeting for today. Thanks everyone for participating, and we've had some good discussions.
Thank you. Thank you, Dan.
Thank you.
All right, thank you.
Thanks, everyone.
Thank you. Bye.